Hello everyone. In this lesson, we will continue studying drafting in NX10 software. Using a practical example to fully learn the process of creating engineering drawings. Let's look at this drawing and analyze the content it includes. A complete engineering drawing must express all the dimensions of the model through projection views. An internal part should be represented by section views. Therefore, we see that this part has 3 views and a section view, with detail views to show finer details. Special requirements, such as positional tolerance, are indicated where necessary, like at the shaft hole, where both ends need to be consistent. Additionally, the drawing specifies technical requirements and surface roughness, as well as an isometric view of the model. Through these views, we can fully understand the dimensions and structures of the model. Next, we will begin the instruction explanation by first opening UGNX10 and loading the clamp body. Then click on Start Drifting in the menu bar, or use the shortcut key Ctrl+Shift+D. A drawing page dialog will pop up. Select Use Template to enter the drafting environment. Invoke the drawing frame by selecting the Replace Template command from the GC View box. Choose the template A3, Assembly No View. Set the parameters and bring up the drawing frame. After entering the drawing sheet, we click to add the basic view. Using the top view of the Vise body, we see that in the task drawing, the main view is a section view, and the top view is a basic view. Since we need to add the basic view before adding section views and other views, we first add the top view. After placing it correctly, we then add an isometric view. Click the top view. Select Orthographic Isometric View from the top-down menu, and the system will automatically switch. Then place the view, typically above the title block. Next, add the main view. The main view is a section view, so the top view should be selected as a parent view to create the full section main view. Select the section view command. Then click the long axis certain line of the top view as a cutting position. Move the mouse upward to place the section view, ensuring the position is directly above. Otherwise, the system will automatically change the view's rotation angle based on the mouse movement. Once in position, click to complete the operation and exit the command. Next, add the half-section side view. Click the drop-down menu for views. Select the section view command method. Choose half-section view and select the fixed hole of the Vise body as the cutting position. Place the section view. Since the main view is full section of the top view, to keep the drawing neat, rotate the half-section side view 90 degrees. Then align it with the main view for placement. After completing the main views, you can add a partial section view to cut within an existing view and display the internal contours of the part. When creating a partial section, first understand the 3 key elements. First, define the cutting range to show what needs to be cut, which should be pre-drawn, usually with spine curves. Second, specify the cutting position within the range. The depth of the cut within the range determines what the section drawing will display. Third, determine the cutting direction, as the view content displayed from the same position can differ depending on the direction. Next, we will demonstrate drawing a partial section. First, click the top view frame and set hidden lines to be visible, preferably as dashed lines. This allows us to clearly see which positions require partial sectioning. We see that this drawing has 2 screws that need to be sectioned, but since they are identical standard parts, only one needs to be sectioned. Click the Sketch Artistic Spline command in the drafting environment, and draw an artistic spline curve at the screw position. After drawing, click Confirm to exit. Then, click the Partial Section command, and the dialog box will pop up. In the dialog box, you will see highlighted icons and grayed out icons. The highlighted icons represent the current operations to be completed, while the grayed out ones are subsequent steps. Subsequent steps will only be generated after completing the current one, and they must be done sequentially. Select the top view as the parent view for the partial section view. Define the base point at the pole position in the side view. So click the center of the threaded hole in the side view as the base point. Afterward, continue to define the vector direction, selecting the axis direction of the threaded hole. Then click the Join Spline curve at the cutting line, and click Confirm to complete the creation of the partial section view. Next, add a detail view. The threaded hole just section is small on the drawing and unsuitable for dimensioning. So, we will create a detail view to facilitate dimensioning and content display. Click the Detail View command. Set the method to circular. Specify a point on threaded hole axis as the center point. Drag outward to set the arc boundary, and select the top view as the parent view. Click a blank area to place the detail view. Set the view style and symbols, and click Confirm to complete the detail view creation. After generating all the views, the next step is to dimension the views. Click the Quick Dimension command and sequentially dimension the top view, main view, side view, and detail view. Each dimension only needs to be marked once. The drawing has two threaded holes, which can be marked as 2, M6, 1. Here, 2 indicates 2 holes, M6 indicates the thread type, and 1 indicates the pitch. Dimensions in the half section view can be represented with a single arrow. After completing all the dimensions on the drawing, you can compare them with the task drawing to check if the dimensioning is complete. After completing the view dimensioning, you need to add certain lines to all views, especially circles, which must have certain lines. Click the 2D Certain Line command and choose Curve as the type. After setting all the certain lines, click Confirm to exit. Next, add Surface Roughness annotations. Select the Surface Roughness command, and choose the Material Removal style from the modifiers. Click the position to place the Surface Roughness symbol. Set the content, and annotate the dimensions with surface roughness requirements. Click the Datum feature symbol, and the system will pop up a feature dialog box. Enter the datum. Click the shift hole in the main views at the datum. After setting the datum, click the Feature Control command, and the system will pop up a feature dialog box. Choose the coaxiality datum. Enter the geometry tolerance phi 0.012 and mark the 525 circle. Create annotations. Click the Annotation command to add technical requirements. Here we write, the casting should undergo artificial aging treatment. Click to place it and confirm completion. After completing the engineering drawing, be sure to save it. In this lesson, we use the Vise body as an example to demonstrate the process of creating a part drawing. Please practice more after class to become proficient in the operation. See you in the next lesson.